Morning everybody. I think I got myself really confused what day it was yesterday. So I said something in the video and then I think I said something else in the homework task. Just to clarify, today you're not doing a topic test. Today we are doing inverse trig functions. Tomorrow you will do a topic test. So that's inverse trig functions today, which is definitely Wednesday. Topic test tomorrow, which is Friday. And then we can start something new on Monday. So hopefully I haven't worried too many people or got too many people are confused about what's going on. I'm sure I've got everyone confused, but never mind. So we're going to start doing some inverse trig functions today. I'll start with an apology, I'm afraid. It's my childcare day and I didn't get this done in time. So currently I've got a helper who's there building some Thomas tracks. Max, you want to say hello? No, he doesn't. However, undoubtedly he will probably disturb me at some point, so I do apologise in advance. Okay, so inverse trig functions. So to get going with inverse trig functions, the first thing we need to do is just remind ourselves about inverse functions in the first instance. So here is a graph, it's y equals x squared. From our functions chapter, hopefully you'll remember that one way of getting an inverse function, at least graphically, is by reflecting in the line y equals x and then doing some other stuff. So what I'd like you to do first thing today is, can you draw the inverse function for y equals x squared by reflecting it in the line y equals x and considering whether you need to do anything. So just have a go at that, pause the video and then come back to me. Okay, so hopefully what you drew was just this bold line here, and you put y equals root x down. The reason why I've got this dotted line here is because if you draw the line y equals x, if you reflect this in this, if you reflect y equals x squared in y equals x, you will get a curve that looks like this, the dotted line included. However, remembering about functions, functions need to know where they're going. If we left both of these things, if I picked a value of some value of x here, for instance, I wouldn't be sure whether to go up or whether to go down. So functions have to know where they're going, so we had to basically restrict the range. We need to get rid of this bit here and just allow these values instead. So moving on from that, what I'd like us to do next is have a think about trig functions instead. So what I'd like you to do is, could you draw y equals sine x, please? Can you draw y equals sine x between, in fact let's do cos x, cos x would be better. Let's do cos x, and can you do cos x between 0 and 2 pi? And then can you try and reflect this in the line y equals x and see how you get on? Come back to the video when you've done that. Okay, so if you reflect cos x between 0 and 2 pi, if you reflect that in the line y equals x, you should essentially get something that looks like this. I've ended up changing around, I've changed around these numbers. Sorry, I haven't changed around the numbers. Obviously, it was originally on the y-axis, it was at 1, so it goes to 1 on the x-axis. And so what I get is this curve. Now, the problem with this curve, I hope you can see, is that it's not a function. It's not a function because if I pick a value, let's say here, and say what is the output for this input, I won't be sure whether to go to here or whether to go to here. So, and I've restricted cos x between 0 and 2 pi. Cos x also goes on forever in both directions. So if I did no restriction whatsoever, I would have infinite amount of values which it could possibly go to. So that wouldn't be a function. If I restrict it between 0 and 2 pi, I've still got too many options. So we need to restrict the original function even more than that. And hopefully you can see from here, if I restricted my original domain between 0 and pi, then actually for any point, any input, I'd only get one output, because it doesn't, the function doesn't come back on itself until this point here. So if we have y, well actually let's just do it this way. So if we have f of x is cos x, and we let the domain be 0 to x to pi, we know that the range for this, that's not how you spell range, you know the range for this goes between 1 to minus 1, and so f so if we restrict cos in this way, we can get an inverse function, and the inverse function we call arccos, or arccos of x. And then to think about what the domain and range need to be, if you recall from our functions chapter, for functions and their inverses, the domains and the ranges just swap places between the original function and the inverse. So the domain will be minus 1 to x to 1, and the range will be from 0 all the way up to pi. And hopefully you can see this from this picture here, if I just covered the rest of that up, not very well with a clear ruler. The domain is the input, which goes between minus 1 and 1, and the range is the outputs, which go between 0 and pi. Okay, so what I'd like you guys to do next is have a look at sine x. So have a think about, so draw the curve for sine x first. I would suggest you go a little bit in the negative direction, a little bit in the positive direction. Think about what restriction you should put on the domain such that you get an inverse function, and the inverse function is called arc sine. So can you have a quick go at that? Once you've done that, can you come back to... Thank you, Max. Can you come back to the video? Okay, so hopefully for sine x, you realise that if you did between 0 and pi, like you did for cos x, if you do between 0 and pi, you get this shape. And obviously if you reflect this, you end up with something which isn't a function, so this wouldn't be the right thing to do. So the right thing to do is get rid of that bit and come back slightly in the negative way and reflect this bit in the line y equals x. And if you reflect that in the line y equals x, you get this. This is y equals arc sine x. So think about again what the domain and range of this would be, and to do that, think about this. So originally the domain was between minus pi over 2 and pi over 2. So if the domain was that, then the range of this one is going to be minus pi over 2 to pi over 2. And for this one, the range goes between minus 1 and 1. The range for this is minus 1 to 1. Then the domain for this must be minus 1 to 1. Ranges and domains swap positions with inverse functions. Okay, so I'm going to let you guys just have a look for the tan one yourself. You can have a think about that one. You can check it. It's on page 159 in your textbook if you want to see the tan one. What I'd like you guys to do for the remainder of today is just get used to working with these functions a little bit more. I'd like you to also try and practice using your exact trig values. So values for 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees, or even nicer than that, we've got 0, pi over 6, pi over 4 and pi over 3 and pi over 2. Which you want to work in radians or degrees. A quick note on example 14 in your textbook. I have absolutely no idea why they are asking you to solve some equation. Just use the button on your calculator. Just do shift sine or shift cos, shift tan. That gives you arc sine, arc cos, arc tan. You should find that when you do shift sine, if you stuck all the possible values in between -1 and 1 for shift of sine, obviously there's infinite amount, but a sensible amount of them, you would just get this from your calculator. That's the only thing the calculator will return for you when you do shift sine. Shift sine on your calculator is arc sine. So what I'd like you guys to do is actually just do some practice with some of these bits on the next page. So can you have a go at exercise 6e. Don't worry about doing question 1, that's a bit daft to say the least. So please do question 3. 1 second, Max. Question 4 as well. And then for something slightly more interesting, can you do 6, 7 and 8? In fact, let's get rid of... No, we'll leave it as that, 6, 7 and 8. With question 3, think about if you do a function and then you immediately do the inverse function, have you done anything at all? Okay, so I'll leave it there. Sorry for this being a bit late, and I will set the test for you to do tomorrow. Please email me if you have any questions about today's work or anything from the chapter so far. Your teachers should be returning your test to you at the moment. I'm sorry if I'm a bit slow returning tests to people. I've got quite a lot going on at the moment, which is causing some issues data-wise, and obviously making these videos, but Mr. Gatorby and Mr. Clark are helping me out as much as they can. Speak to you again soon. Have a nice day and have a nice bank holiday weekend. Max, do you want to say bye-bye? We'll do a little wave? No? Not even a little bit? Go on.